Hi, Randy K7AGE with my second Arduino video. In this video, I'm going to show you where to download the Integrated Development Environment, the IDE software, get it installed on the computer, be able to open up a sketch to blink an LED, and be able to upload it into the processor here, and how to make some basic changes. So that's what we're doing in this video. And I'm going to be following along in Dr. Jack Purdum's book, Arduino Projects for Amateur Radio. In Chapter 1, he tells you how to download and install the Arduino Integrated Development Environment, the IDE, how to install the software, some of the screens that you'll be seeing, and drivers that get installed, connecting it up and running your first program. So, okay, to get the software, we go to the www.arduino.cc website. I'm at the home page. You select software. And it brings up, there's two IDEs. There's an online, which I've never used. And then in this area, you can download the Arduino IDE. And it's available for Windows, Mac, Linux. So I'm going to download the Windows installer. And they take you to a page to support the effort. If you want to contribute to the Arduino Association, that's fine. I'm just going to hit the just download button, and now the software is downloading. It's 89 megabytes, so it may take a while depending on your speed. And it's finished downloading. Okay, one of the things that Jack recommends is that you create a folder to put your Arduino software in. Otherwise, when the software installs, it'll put it into the C drive, programs, files, x86. So it's a little harder to find things. So I've created a folder, Arduino, and I'm going to open that up, and I'm going to put another folder inside, another folder, Arduino. And the software I downloaded was version 182. So I'm just going to call it 182. So if I download a newer version at some point in time, or maybe I want to go back to an older version, I can create another folder in here and have multiple versions of the environment. So I'm going to open my Arduino 182 folder. So I'm going to go back to my download page. Here's my file I downloaded, and I'm just going to copy that into the directory here. All right, I'll install the software now. Double click on the file. I want to say yes. And I agree. So let it install everything here, the software, the driver, the shortcuts, and it will associate the .ini files, which are the Arduino sketches. So when you double click on one of those, it'll open up the IDE. Destination folder, I do not want it there. I want it on my desktop. My Arduino directory. Arduino 182, so I'm going to put it in there. Arduino 182, and install. And this may take a little bit of time. And it's completed. So that took several minutes for it to do that. And I guess we're done. So when I got done installing, it created another Arduino folder. Let's double click on that. Now this is the whole IDE environment. So there's lots of other folders in here. And so here's drivers for the various boards and things for the USB. You really don't have to pay attention to what's in there. Here's where all the example code sits. The libraries that come with it. So all sorts of things that you may or may not need in the future are waiting for you. And here is the Arduino.exe. So we double click on that, and that brings up the Arduino screen here. We got a firewall is blocked, so I'm going to allow access. There we are. It's up and running, and let's take a look at this a little closer. I'm going to get rid of the background screen here. We don't need that anymore. So the next thing I'm going to do is plug in the Arduino board to the PC using a USB cable with a Type B connector, the square one. And I plugged that into the Arduino board, and the computer made its noise and found it. Okay, I'm back to the software now, and I'm going to make a little change here. I'm going to go to Preferences. I'm going to say go to 16, make the font a little bit larger. Let's make it maybe 20. See how it shows up on the screen. Okay, so that's larger, and I'm going to increase this to fill up the screen a little more. So this is a basic, simplest Arduino program. It has two functions. There's a setup function and a loop function. So every Arduino sketch or program needs these two items. So right now it's not doing anything. So this is your base skeleton code. So two things we need to do here is first go to your board selection, and we want to select the Arduino Uno board. And the next thing we need to do is select the serial port. I'm going here to port, and here on my computer it shows up as COM3, and again it's the Arduino Uno board. And if everything goes right, I should be able to compile this and upload it to the Arduino board. So to compile it, I can just click on the verify, and it says compiling the sketch down here, and the progress bar. Taking a little bit of time. And it's get something about archiving code, but it says this sketch uses 444 bytes, 1% of the program storage. Maximum is 32,256. Global variables use 9 bytes. So we were able to compile it correctly, successfully. So when you press the arrow button here, it both compiles it, so it'll recompile. That was quicker. And now it will upload it. And I don't see any errors, so that must have worked. So I just want to go in a little more in depth of what the setup and loop functions are all about here in the Arduino sketch. These must be in every sketch. The setup code will execute once when the program starts up. So this is where you may initialize a value. You may initialize a pin on the Arduino to be an input or an output or whatever. So those are things that you do to set up the code that you only need to do once. Then it progresses to the loop function, where all your code in here will execute over and over and over again. It'll go down through the list and then go back up and start from the top here. Void means there's no information being returned back from the function. Some functions that we'll see at a later date, you will pass data to the function. The function code will act on it and then return back some type of data. So the void here means that there's no data coming back. All right, so let's make the LED blink. So I'm going to bring up the example sketch. So File, Examples, Basics, Blink. Opens up another window here. I'm going to move it up. And it starts off here with some comments that talk about what this sketch does. And we know it's a comment because the text is gray, and the comment here is opened with a backslash asterisk. So that's at the beginning. Everything between there and the asterisk backslash signifies that it's all comments. And this talks about that we're going to turn on the LED for 1 second and then off for 1 second repeatedly. And it says most Arduino boards have an onboard LED, and on the Uno, it's attached to digital pin 13. And there's some other things here which you can take a look at. Then down here is the setup and the loop functions. Here's a single line comment. This is just 2 slashes. So anything following the 2 slashes is a comment. The void setup, another comment, says it initializes the digital pin LED built in as an output. So pin mode is the command. LED underscore built in tells it which LED to use. It's going to use the built in, and that the pin is being set to be an output pin. So that's all that happens in the setup. The loop function here runs over and over again, and basically it does a digital write, that's a command, of the LED underscore built in. We're going to set it high, so that's going to turn it on, followed by a delay of 1,000 milliseconds. So there's 1,000 milliseconds in a second. So this turns it on, waits a second, Here's another digital write that turns the LED off, or by setting it low, turns it off. And it waits for another second, and then it goes back up here and turns it back on. So if I select the arrow here, compile and upload the code, and I don't see any errors, and it compiles, you can see the LEDs blink for the data transmission, and now the LED here is blinking 1 second on, 1 second off. Let's change the code to make that blink differently. So before I change the code, I'm going to hook up an external LED so we can see it easier. I have this big red one, and the LED on the board here is connected to pin 13 on the block. So I can use an external LED connected to pin 13. I'm going to feed it through a 330 ohm resistor, because that's what I happen to have, and back to ground, and we'll have an external LED. So let me hook that up. Okay, so let's hook up our external LED. We're going to use the breadboard here to do that, and I'm going to use a jumper wire. And if you've never used one of these breadboards, these are pretty neat. There's these groups of 5 holes here that run in a row. So these 5 are all connected together, which are separated from the next group of 5. The ones down the side here, these are connected all the way down the board, and these are labeled minus and plus, which is where you can hook up jumper over the power supply voltages here to have those bust. Now the pins on this side of the board are separated from the pins on this side. So like a integrated circuit can span across the junction here. So you could have 8 pins down this side and another 8 pins down that side. But we're just going to use a jumper wire here in the LED. So the LED is on pin 13 on the Uno. So I'm going to put a jumper cable in there. I'm just going to pick a pin over on this side. And here's the LED. And the long pin is the anode. So that'll go towards the voltage, towards the positive voltage. So I'm going to plug the longer lead in the same row as the red wire that goes over to pin 13. And now I have a 330 ohm resistor because I just happen to have one laying around. And I'm going to push that in the ground pin on the Uno here. And I'm going to put it in the same row as the second pin of the LED. And you can see we have the large one blinking here. Okay, let's go back to the sketch and make it blink differently. Okay, let's take the code here and copy it. And I'm going to paste it in here. So we now have it turning it on, turning it off, turning it on, turning it off. So here's a second on, second off. Let's make this, say, 1/4 of a second, 250. And so it's going to be a fast flash, and let's leave it off for, say, a 1/2 second. And I'll press the button and compile it and upload it to the module. And we'll see the transmit and receive LEDs blinking on the board. That means data is passed back and forth. And now the blink rate is different. There's the short, the long, short, long. So we were able to change the code and reload it up to the board. So this wraps up my second Arduino video. I showed you how to download the code, where to get it from, how to install it, how to select the board type, the COM port, how to open up a sketch, what the setup and the loop functions do within the code. I opened up the blink sketch, downloaded it to the module, blinked the LED, hooked up an external LED, and varied the code to make it a long and a short blink. So the challenge to you now is to make the LED blink SOS. So it's dit, 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 da, 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 dit, dit, dit. 3 shorts, 3 longs, 3 shorts. And down here, I'll let you read this on your own, but it describes the timing durations for dits, das, the space between characters, and the space between letters. So you can do this yourself with just a lot of code. It turns the LED on, wait, turn it off, wait, and by varying the amount of on and off time, you can have it send dits and das, and generate a code to send an S, generate the code to send a O, generate the code again to send an S, wait, and then let it repeat. So the LED will be blinking out SOS. So I hope you enjoyed this video, and you can show me that by pressing the thumbs up button. If you haven't subscribed, please press the subscribe button. You can follow me on Twitter at K7AGE, and you can follow me on Google Plus at +K7AGE. So thanks for watching. This is Randy, K7AGE.